All right, hello and welcome to the next Nix Hour. So if you want to ask a question yourself, please join the meeting. It's in the YouTube description. And you can use voice or chat. All right, so today we have a question about the module system, about how to do data validation, like validating IP addresses, other string-like structures, or anything else really. And so let's look a bit at that. So I guess I want to start off here just writing a module. We'll get to evaluating that a bit later. And so the module system has, I'd say, two core features, and that is, one of them is type validation and the other is merging those types. And this is both implemented with the types. So let's look at this like this. So let's say we declare an option using the module system. I'm declaring a module here. And let's create an option, lib.make option. The most important thing to set for all options is a type. And so that does the typing and the merging. And so we have lib.types implementing a lot of these, and let's just use str. That's a string for now. We need to make sure lib is accessible, so let's add that as an argument. And now I want to evaluate this. Let me create a separate file to do that. So I'm going to do, actually I created like a small template here. Hopefully I can reuse this for future Nix hours, but this should also have a module eval, I guess. And in here, I'm just gonna do a lib.eval modules. And then we pass this module into here. All right, and that should be enough, actually. All right, now we can evaluate this. Let's use nix instantiate eval and -a module eval.foo. And path not found, it is config.foo, so the result of eval modules has config and options, most importantly. So we can config.foo to access the option. Now the option is not used, is used but not defined, because we accessed it but we didn't define a value. And let's just set a default here for now. All right, that works. We get the empty string back. Yeah, so, right, one of them is apply, was just mentioned in the chat. Let's get to that in a bit. So let's just demonstrate the checking here a bit. So what if we set an integer here that is prevented by the type? Let's make this a bit like this maybe. Yeah. So this is prevented by the type. It has to be a string, and it detects it's not a string. Right, it also does merging. So let's say we have a config.foo equals, let's use lib.make merge. That's as if you have two definitions of the value. So let's say we have a foo here and a bar. Let's not set a default now. Now we have conflicting definition values. But we can say lib.types.lines, for example. And lines allows merging of different values. And in this case, it merges them by just concatenating with a new line in between. And so from this, you can see that types really specify two things. They types both check and merge. And yes. And so if you want to check some additional properties, so let's say we have a string, but we want to make sure this is a valid IP address or IPv4 address, so like 10.0.0.1. That works, but if we were to specify foo, this should fail, which currently doesn't. We can do this in different ways, and there's there's different ways. I'm not sure what the trade-offs are just yet. But so there is lib.types.add check, I believe. Let's actually look at the manual. Gonna go to the Nix OS manual. So even though this is a kind of Nix packages lib specific feature, the module system and the types, it's documented in the Nix OS manual because Nix OS is kind of one of the main use cases of the module system. So in here, types or option types, I think I skipped the section. Oh, maybe not. Let me actually go up here. Declaring modules. Declaring. Oh, this is hard to find. Okay, let me go. Anything is a type. It might be easy to find. Yeah, here. All right, option types. Yes. So, okay, all of these write the standard types, but there should be one to add an extra check. And where is that? Submodules, we have lists, edges of coerce to submodules is also a separate type. We have check. Oh yeah, here it's mentioned. So it's add check. Is it also somewhere else? Oh no, it's only here. Okay, this is apparently it's a bit weird. It doesn't mention add check here, but it does here. Okay. But yes, so this is how you can add a check to a type. So let's try that. We're going to use add check. So the first argument we saw is the type itself. Yes. So in here, we just add a function to do the extra checking. So we have a string, let's call that s. And now, let me actually do this like that. All right. Now we can use built-ins.match. It's kind of an easy way to check validity of strings. You can check regexes against it with that. So let's say, so IP address, that's like well, I'm sure there's kind of more complicated IP address regexes out there, which do a bit more stricter validation. For now, I'm going to do it like this. A dot. We need to make sure to doubly escape the dot, actually. Well, to escape the backslash so it gets interpreted by regex. I'm thankful for the syntax highlighting here. And so really just this a couple times over. All right, the final dot we don't need. Okay. So we have the regex and then just pass s. Now, functional programming, we can kind of eta reduce, I believe it's called, where we can just omit the argument because it's, we pass it as a function. All right, and now let's test this. And well, built-ins.match doesn't return true or false. It returns the matches or null if there's no match. So actually what we need to do is we need to get the argument back. So kind of just undoing what I did before. And we want to check that this is not null. So we do not equals null. This is a bit messy though. Let me refactor this a bit. We have a let-in statement here. So just in the Nix language, sometimes it's not entirely obvious, but you can always have these let-in statements for any expressions. In this case, I want the variable, I only need it kind of locally to here. So I'm not gonna like put it up top here or anywhere. So let's do the IP regex, assign this as a variable. All right, like this, and this is then IP regex. All right, and let me move this up here. Okay, check this again, and we get this, a definition of option foo is not of type string. So this is now a bit confusing because it is obviously a string, but the type description wasn't updated. So I believe when you go to Nix packages, let's do that here. If you go to Nix packages and search for add check and do like add some context afterwards, we can see not here. add check. These don't do it. Check desk. Yeah, actually not a lot of them do that. I think sometimes you can find the description also being overridden. Yeah, I can't find an example right now. Oh, here's one. So it does a types.addCheck and then also overrides the description. And why this almost feels like it should be part of the module system itself. Why is this in this random module? It's an interesting question. I guess sometimes in Nix packages, you want something just locally, but aren't sure yet if it's a good abstraction for the kind of lib module, which has kind of stronger, well, it's a public interface lib, so it needs like documentation, it needs tests ideally and stuff like that. But in this case, it's just local to this module and not exposed. So that's why sometimes you'll see some useful functions in modules. I do almost believe I've seen this being in a PR. Maybe it wasn't merged though. But yeah, let's do the thing with the description ourselves manually here. So let's do an update here. So types are really just attribute sets, so we can just do this like that. And I'm going to, actually the formatting here is a bit ugly. Let me refactor this a bit, maybe like this. So the description, we want to override that, and we're gonna say string or like IPv4 address. All right, and let's run this again, and we get a better error message now. All right, and yeah, there is some types in the module system that have some validation as well. So if we go, I mean, we've seen the documentation just earlier. If we go up here, yeah, so we have like integers, there's some validations for that within some ranges. We also have a port number that's useful for services. Floats number, we have number that's either a integer or float, relatively new. Okay, we have separated string, comma string matching. Oh, string matching actually is pretty much exactly what we need here. So we can actually use this. Let's actually check implementation as well. See if that does anything special. String or str matching. Yeah, that pretty much just does the same thing. It does the string check and then it does the pattern match check. Yeah, that looks pretty good. There's also a description class here, which actually we might see not working properly if we nest this. Let's try this out. What if we create a custom, or what if we do a Latin for our type here? So we say IPv4 type equals this. All right, then IPv4 type, let's just verify this still works. Yes. And so now what if we say we have an address of IPv4 type? So now instead of it just being a single one, actually let me remove the make merge here. Instead of just a single one, we have an attribute set, so we can say foo equals foo, which again should be valid. And address of is undefined, it's lib.types.addressof. And it's lazily evaluated by default, so let's add a strict here. All right, and this seems like the appropriate error. Yeah, I feel like it's hard to demonstrate that. This description class, it's mainly for the description when it is printed to be properly parenthesized, I believe. But yeah, let's not do our custom one here because we can just use lib.types.str matching. All right, and so I believe in here we just have the regex then. And so let me actually refactor this. I'm going to put the IP regex up here, out of here. Okay, I'm going to add a prime here so we can, so it still works and doesn't conflict. And then string matching, I believe just the IP regex here, right? Let's check the docs for this. Yes, well, they're a bit short, but that seems to be what it does. Let's see if it works. All right, yes, it works, although the error is a bit worse, to be honest. So we might still benefit of an overridden description here, like this. Just copy that. All right, so we get the same thing. Minor improvement. But yeah, so there's other ways. Let me actually undo this. Just one. This. Okay. There's other ways of doing this as well, though some of them aren't as well. So another approach is to use apply. So apply is a bit dangerous. I am going to try to get to that later in like various cases, but just for checking, it is not terrible. So in here, so apply, what it does is after the final result of this option is computed. So, all right, let's say we do like a, well, let's demonstrate this with lines maybe. Well, this is bar lib.types.lines. And say we have bar, okay. And let's assign this twice. So let's again use a make merge. Okay, so we have foo and bar. Let's merge these together. Oh, and foo, now we have bar. Okay, it's merged together. And so the apply allows you to apply a transformation on this resulting value here after they have been checked by the type and after they haven't been merged using the types merging function. So in here we could say, well, actually, let's prefix this with like a, it's a function, we can take the final value and we can say prefix this with the lines are colon and then the value. All right, and if we do this, evaluate the option again, we get an error because I have a colon. But yeah, we get this changed value. And so this is, this is what apply does. But in this case, it's a bit dangerous because it can change. Well, it changes kind of what people expect, what they get out from. I'd say a fairly reasonable assumption is that if you assign a single value to an option, you expect the option's value to be that single value. But that's not the case here anymore. And so this also means that if you like try to, oh, this is the option's value, but now let me just replicate this configuration by inserting this as the option's definition, but then you would get this back. So it's not idempotent, I guess, is a way to think of it. And this can also be a bit worse. In this case, we maintain the same string, but there's other cases like, let's say we have a list of, and let's say we have a list of strings. All right, and now we take this list and we say, well, actually, let's merge it together here. And let's say we merge it together into a single string, yeah, using, let's say, lib.concat strings sep, and we separate these by new lines, kind of very similar to the previous option. And so if we try this, well, we need list now as the option's definition. Let's say foo. Okay, this might seem reasonable, but it's a bit backwards because the input type here is a list, but we get back the string. And yeah, that changes the type. It's kind of not what people would expect. Yeah, maybe just to show the difference to lines here. Lines doesn't accept lists as values. With lines, you need to pass single values, so like foo. And the, what was the string while a list was expected? Oh yeah, here now the apply is wrong. Well, anyway, so, okay, so apply is a bit dangerous. It can change the kind of types, it can make things not idempotent. But for the case here, where we just want to do validation, it seems okay because we don't change anything about the final value. We just do an additional check and fail if it doesn't match what we expect. So let me actually, does this work? Let me revert this a bit here. Let me revert it to like this. Sure. Okay, so if we want to check the type using the apply, let's do IP option or IP. So we say string, we don't do it with the type itself. And we have an apply, we say we take the string, then we do actually the same checking as above. So this one. Okay. And
you need big types str there.
Oh yes, thanks. Okay, and if we try this, well, foo, we need to evaluate IP now. Used but not defined, right, we need to define it. So let's say config.ip equals foo. We have a bit of a mess here. Let's actually, it's kind of neat how you can just reorder these sections if you use this shorthand syntax in Nix. So we can kind of have these separate sections here. Okay, and so now, well, we get, oh yeah, this is not right. So this returns true or false. We don't want that. We want to return the actual value. And we need to throw when it's false. So to do that, we can use if this is not equals to null, or let's actually use equals to null. Well, let's do it the other way around. So then it's it didn't, well, it matched. Null is a result when it doesn't match. So here it means we did match. That means it is valid. So in this case, we just need to pass along the value, as in this case. With the else, it's that we need to throw an error. So in this case, we can say the string as, let me put that in quotes, is not a valid IPv4 address. All right, and we could also say of the option IP, or the string, yeah, sure. I don't need to make sure it's perfect here. Okay, if we try this, yes, we get an error for that. Now something you can't have here is, and let's actually directly compare this to the previous one. Here, config.foo equals foo. So this error is the string is not a valid IPv4 address. Let's actually, well, sure. But if we evaluate foo, here we actually get the location of the definition and the definition, well, we get that too, but we don't get the location in our IP example. So this apply function here doesn't get the context of where the definitions occurred, and so that it could actually be done manually. So we do have the, so previously I said that the module eval modules returns both config, so that's what we've been using so far, but also options. That's the same as the options up here. So options and config actually as well. You can get these up here. But in options we have IP. So let's try to get the location of the definition here. So IP dot, and then we can see here we have definitions with locations, declarations. Actually, since recently, there's also a declarations with locations, I believe. Yeah, that should be merged. We might have it if we update Nix packages. But for now, we can see declarations. So declarations is where the option is defined. So that's this IP option. So if you look at this, we can see, well, everything is in our single module here. Definitions would be where, actually, this is a bit weird. Declarations is the location. Definitions is the actual value. If we want to look at the files of the values, this would be, I believe, no, lock is the option attribute path. It would be files, yes. Files would be the location of the definitions. But in this case, we could say definitions. Let's make a multi-line string here and say like this: definition values. We can kind of copy the same thing that the module system does. Actually, we can maybe copy it exactly. Let me look at what it does. So that would be in here, definition values. Yeah, here, def text. What does it do? It does some weird show defs. We're really digging into the code here, but I believe show defs is exposed under next REPL. Let's just see options dot show defs. Yeah, it's exposed. Okay. So let's try this. So we want show defs. It is in lib.options. Very confusing. There's two kinds of options in our scope here now. There's lib.options and there's the options from up here. But in this case, we want lib.options.showDefs. We want options dot and then this option itself. So that's IP. Then the files, actually no, the files, I think it's the definitions with locations, probably. I believe showdefs does that. Let's just try it. So we want to evaluate config.ip. And that seemed to work. Yes, let's make it a bit more compact here. Well, let's leave it like this. Yeah, and we can see this is not right now. So the multi-line string doesn't need escaping for these quotes. So we can drop these. All right. And I also want to show something interesting. So let's say, so this would not usually happen, but let's say we have, this is a string. Actually, let's like, I just want a double quote in here, like this is a string. Not sure what that means with that quotation, but let's try printing this. Now we get this, which is a bit weird because we have quotes and quotes nested within it. And a way to kind of improve on this is to say use REPL, let's go into like lib. We have strings dot escape. We have a bunch of escaping functions, and I think probably the most appropriate here is escape Nix string. So lib.strings.escape Nix string, and we'll see what it does. Oh, that's not right. So yeah, we don't need the quotes around this then. So escape Nix string renders strings so that you can reinterpret them in Nix. So we can copy paste this. We can go into Nix REPL and we can get this exact same string back. Well, then it's again, the Nix REPL also does this very same thing. So this looks a bit weird, but if we use like Nix instantiate eval, we can verify this. Well, it actually also does the same thing. So we have to go through either --JSON then do like a raw JSON printing of this. That's jq-r. Or you can also use Nix eval that has a raw flag. So we can say expr print the string. Okay, still does the same thing, but we have the raw flag here, which allows us to print the string as is without any quoting. Just kind of a roundabout way of talking about the Nix escaping. All right, so I guess so. Now the question: should you actually use apply? Because we pretty much just copied the same thing you can do with the string matching or add check. And well, the benefit here would be that you can further customize the error message. So right, we could say here, if you meant to do this, what would be a realistic scenario, if you meant to assign the listener, I don't know, listener something, do that instead. We could do something like that here. And this is instantiate, yeah, right. And we can't do that with the just types here. But generally, I mean, this is a bunch of extra code. It's not very standard. I wouldn't really recommend that. Yes, let's.
But also you can verify some conditions that apply to the result. Like if you have a list of IP ranges, for example, you may make sure that they don't intersect or something.
Right, yeah, that's true. For that, there is also assertions, and let's actually look at that. Right, I think that was part of the question as well. So yeah, let's look at that. Right, but so by default, assertions are not, at least yet, part of the module system itself. They're mainly just a NixOS addition. And so how can we best show this here? Yeah, we might have to write a NixOS module. So let's do that. And for this, I will write a configuration.nix. And write same thing as before. It's just a module. I'm gonna say sure IP option lib.makeOption as before. And so let's say we just say string types.string, and we assign this one as well. Let's say foo again. Well, actually, let's sure, let's do that. Okay, and now we need to be able to evaluate this. So let me copy some standard configuration in here. I believe I have that in there. I really need this template to make this smoother. But yeah, so really just these three options. Okay, and let's try evaluating this. And actually I'm gonna do Nix Hour. I have this default here where I added also the module eval. I'm also gonna add a NixOS eval, and this almost looks like a flake at this point, and you'd be right. And that would be another way of doing the kind of same thing with a more standardized approach. So I'm gonna do a NixOS system here, and for this I need to import from, so I use an if here for the sources, so I need to access this from here, the NixOS directory. This is the kind of entry point for NixOS evaluations. And I need to pass the configuration, that's configuration.nix. And I think that's it pretty much. Yeah. Okay, let's try evaluating this. Next, build, or actually instantiate. I don't want to build anything yet. NixOS system. Let's try this. And undefined variable, that's fair. Need to have lib in here. All right, this should work. And I think, it evaluates too many things actually, yeah. So NixOS provides a config.system.build.top level is kind of the actual result of a NixOS build that would build the NixOS system. In this case, we just instantiate the derivation, so we can just verify that the evaluation works without building it. All right, but so this might confuse you because it didn't throw an error, and that is because we haven't used this IP option for anything. Previously, we just manually kind of accessed the options, and we can also do this here. So we can say config.ip, and then, we get, it's not a derivation, so we need to add eval. Oh yeah, right, we aren't checking the type yet. But yes, it's actually not getting evaluated with NixOS at all. So if we do a throw here, if we do that, it shouldn't throw because it's not evaluated, not needed for anything. To make that be needed, let's do something like, we can say networking.hosts. Is that an option? Hosts? Yes, it is. Right, let's do something like this, an example of something that needs an IP. So let's say our IP, so config.ip. This is how you refer to options, and we need the config argument up here for that. So config.ip, the string of that will be set to, well, let's say this is, I don't know, server. Okay, so this would allow you to like ping server instead of having to list the IP address in the final NixOS build. Okay, let's try this now, and we should get an error now. Yes, we get our expected error. So yeah, and if we try to build it like this, this option itself might have some validation. It doesn't seem to, but that's okay. We're gonna add it now. So right, I wanted to show assertions. That's why we did this. So let's have an assertion. So that's a NixOS option. I believe it is in the manual as well. It's not. Or did I just... No, it's not. That's not great. Why is that not in the manual? Let's just dig real briefly here. NixOS modules, I believe, well, assertions equals make option. Let's search it like this. MISC assertions, oh yeah, it's marked as internal here. That makes it not be rendered in the manual. I don't think it should be labeled as internal though, but that's another topic. But yeah, we can still use it. And so I guess we can check the source here for the documentation. So right, we have an example here. So we really just need assertion and a message. And if the assertion is false, it will throw the message. And so it's a list of things. So let's do it like this. Okay, assertion, we are going to say assertion is, now we can do the actual thing we want. And I'm going to copy this from the other module here. This check. Assertion is built-in match not equals null. Yep, that sounds right. Then here we can again have our message. We can say the option that's IP, like this. IP is not a valid IP before address. Okay, and again we can print it as well. You can improve the error message a bunch more. But this is the gist of it. And right, we need to define the IP regex. Let me copy this from up here. Sure, actually since we have the opportunity here, let's use a third file just to abstract this. So let's just do, well, it's very specific for now. Let's call it ipregex.nix. And actually, let's make this a bit better. Well, yeah, let's do ipregex.txt. This is a bit weird, to be honest, but it's an opportunity to show something. And so let's say it's just a text file. And so we don't need to worry about this escaping here that we needed to do specifically for Nix. And right, this way we can just read this file from Nix and turn it into a string that way. And actually, maybe, is there ipregex.txt, ip.regex? First time using this file extension, but no syntax highlighting, at least in my editor. Well, it doesn't hurt to use a different extension. Okay, so now we can refactor this. We can say built-ins.read file ip.regex. Same in here, the configuration.nix. We're gonna say built-ins. Let's make this a bit bigger. Read file ip.regex. All right. I wouldn't do this normally. Let's maybe refactor this later if we have time. Okay, now let's try it out. Undefined variable s, right, we need to pass the option value here, so that's config.ip. I'll just get rid of this. Okay, and yes, we get the assertion being triggered. All right, and so that works, but we could also do that with the types before. But what you can do with types is kind of easy validation across multiple options. So let's, for example, say, so this is very kind of arbitrary, but let's say IP, actually that would be, sure, IP prime. And so we say that, okay, we assign both, but we say that only one of them can be an IP address. Yeah, kind of weird, this example, but sure. So IP prime, and now we can say, oh, actually, so this is the regex is valid equals this, or let's say this is a function again. And so now we do in, so we want to say is valid config.ip, or yeah, let's actually do either of them has to be an IP address. That makes a bit more sense. Well, no, it doesn't make any sense, but let's do that. So now if both of them aren't an IP address, we should get the error. And actually the error should be adjusted. Both IP and IP prime aren't invalid IP addresses. Sure. Shouldn't worry about grammar when just showcasing this. But yeah, so this allows us to kind of check multiple options together. And right, if we change this back to an IP address, let's actually use a private one, like this. Then, this either should be valid. That shouldn't be the case. Okay, that something isn't right here. Let's do this. Right, let's debug this briefly. Let's go into Nix REPL. I'm just going to copy this from here. Is valid. Okay, is valid. Let's just check foo. False. What about 10.1.1.1? That is also false. So something I think went wrong here. Is it the read file? Oh, it is a read file. Yes. So actually we can see this if we just do it like this. This has a new line at the end. So that's not great. We don't want that because that messes up our regex. Nix, when it does this with match, it inserts like a dollar a what is it, a bracket, angle bracket in front and at the end automatically. So if you have foo and you have a string ABC foo bar, it won't match that because it has these implicit specifiers in front and back. And so you would have to do this to match that. All right. But yes, so in here, we don't want this final new line. That kind of messes things up. And the kind of best way to get around this, I think, is using lib dot, I think it's file contents. This reads the file and strips a final new line. And the new line is there, by the way, because all the editors kind of have a new line when you edit it manually. Yes. So if you try this with file contents, let's see, let's run this again. And it works now. Yes, this is what we wanted. Very good. Okay, so this is assertions. Was there something else about checking? I can't think of anything right now. So maybe let me briefly read the chat. I think there's a question. Okay, I have a small library that I built that wraps Nix templates. I wonder, what do you think about the general direction code usage there? Yeah, we can take a quick look at that. Yes. All right, so this was mentioned. Snippets, editor agnostic snippet and template tool. I'm not sure if we can do any live code review, but maybe we can look at the interface, and if I have anything to suggest, I can do that. And it's also a way, and I don't mind that, it's a way to just show off kind of things happening in the community. And I don't mind showing off some tools here and there. So let's see what it does. Aiming at enhancing template management within the Nix template system. So maybe just brief note, the Nix templating system, I guess you mean Nix Flake init. We just looked at that before the Nix Hour as well, actually. Nix Flake init. Yes. Init, let's look at this. Nix Flake init. Yeah, so this is about the templates. So we have Nix Flake show templates. We have Nix Flake init, which creates a directory from a template. And I think that's what's being mentioned here. But this is still experimental, warning up here. And the CLI is actually being worked on recently. If you're interested in the progress, you can go to this issue here. The Nix team is working on this and just kind of laying down the groundwork for, or laying down the decisions for the CLI, and then it can be implemented later. So, okay, installation, how manager installation, okay, usage. Initialize a template with a specific name on Nix init-t. I think that's, or actually maybe that changed only recently. I also thought it was Nix init at some point. It might be Nix Flake init now. Search, okay. This is, this is a, is this, what is this, Vim? I suppose this is probably Vim. Yes, template folder. Basic. So I guess this exposes templates here. Inherit templates. Templates come from templates.nix. Yeah. Oh yeah, I should read chat a bit. It combines a couple of tools: xclip, rgfzf, red shell scripts, descriptions. Yeah, I don't know if I have a lot of feedback on that, but let's take a look at some like Nix web sticks. Yeah, sticks, just brief mention as well. Although I don't think it's maintained very much anymore, but it exists. It's a static site generator using Nix, and so apparently this is a template for that. So we have flake.nix, we have a site which apparently declares the index. Nice. Right, the default.nix or flake.nix is most important. Yeah. I honestly don't fully get it yet. So I guess this is mainly a bunch of templates. And Snippix basic. Oh, the default.nix is most important. Let's take a look at that. Oh, I see. Yes. Okay, so in the end, oh, you do a symlink join. Okay, so I see. So you combine a bunch of tools together here. We have pass through, we have some paths. These are, you use a rec here. That is sometimes mentioned as an anti-pattern. Maybe you can link to this here. Best practices here. Yeah, sometimes this is mentioned as best practice to avoid. Sometimes it does make sense, but it's rare. It can be confusing a bit. But let's skip over that. Yes, indeed. Chat mentions that it's kind of easy, and when you are lazy, it's easier to do this than have a let-in definition. But so it seems to declare a lot of write shell scripts, I see. So it maps this over write shell script. There is a lib.fix here as well. Okay, so I guess this, I see. So you have shell scripts that depend on each other. Yeah, that is interesting. Let me actually clone this briefly and just dig into the code a bit more. All right, default.nix, okay. Oh, I see. So there's an init, and that is based on Nix Flake, and then we have snip, which is a snip tool, and that comes from up there. Oh, and that is a copy paste. I mean, overall that looks like decent. There's map address. Yeah, so we have some chat messages here. All right, fixes to allow script to call itself. It is a pattern that I use a lot during my last 7 years of Nix. Yeah, so maybe brief words on lib.fix. Lib.fix is not very extensible, but there is a way to kind of make it more extensible. So let's just briefly go into Nix REPL with lib loaded, and let's look at fix. So right, let's say we have like x equals 0 and y equals self.x plus 1. Okay, so we evaluate this, and the result of this is just an attribute set, and this is kind of done. You can't really change anything anymore. If you want to change something, you can use the update overrider, like say change x to 1, but this doesn't automatically update y, so the kind of function here was lost. There is a version of fix that I don't think has a lot of use cases, but I think it's fix prime. Yeah. So fix prime allows, kind of propagates the function itself using this result.unfix, and in here do like some overriding business, but instead I would recommend using, if you want it to be extensible, use make extensible. So that's lib.makeExtensible. And this is pretty much like lib.fix. So we can do result. And actually we also get the unfix here, but we also get the extend and write the result as well. So we can say result.x.y, but we can also say extend and then using overlays. So here let's use final pref, and now we can say actually change the x to its previous value, so pref.x, but add 1. All right. Now we can also see that the y automatically updated. So that's just something kind of the next step after lib.fix when you need the extensibility. And let's maybe briefly look at the Nix packages manual. Sure, unstable for the latest state. And yeah, lib, we have function reference documentation for all of the lib functions here. Well, not all of them, I think, most of them. And the kind of fix and extends is in here, lib.fixed points. So we have the lib.fix, we have the fix prime that we saw here. We have this converge, which is doesn't have a lot of use case, and to be honest, I think it should be removed, but there's, maybe I'll show something interesting here. There's extends, oh, that's just overlays, kind of used underneath by Nix packages, and extends, make extensible as well. All right, we have make extensible. We have compose many extensions that can compose multiple overlays into a single overlay. It's kind of nice. And make extensible with custom name. I haven't seen a lot of use cases, but it's there if you need it. Maybe something kind of interesting with converge. So this is really just for the fun of it. But so we have converge, and let's actually do. Oh, I think I forgot how to do that exactly. Actually, is it in my history? Not quite. But yeah, let's say converge really just takes a function and initial value, runs the function many times until it doesn't change anymore, and it detects that using kind of equality comparison. And so we could say, like, simple, just divide x by 2, and then we provide the initial value. Is it here? Like 10.0. No, it's the other way around. 10.0, so that just returns 0. What if we add 1? Okay, that returns 2, so I guess it like divides it by 2, and then we get kind of a fixed point out of that, because I think 2 divided by 2 plus 1 is again 2. It doesn't change anymore, so it converged to a point. There's also an example you can do using computing the square root, but that's getting into maths stuff. I don't think we should get into that. Yeah, so converge looks very similar to lib.fix, but it's kind of completely different. So we can look at this, the implementation as well. That's fix points. So fix is really easy. So this is what fix looks like. And so fix works using laziness, and it doesn't do any like equality comparison or so. It really just works based on laziness. And so and if we tried this using lib.fix, it would not work. So let's say fix of this, it would just infinite recursion. Yeah. So lib.fix only works for values that kind of can be partially evaluated. So we could do like right as before, b equals x dot a plus 1. We have attribute sets. Those can be, so like a can be evaluated first, and then b can be evaluated. We have lists also work, so we can say the first value is 0. The second one is elem at x 0 plus 1, so we get the 0th element and add 1 to that. That also works. And then you can also have functions in here. So you can say, I return the function. I think you can do something with, I'm not going to do that now. We are out of time. But yeah, it's interesting to look at these. But yeah, let's conclude it for now. Thanks for the question. I'll stay around here a bit longer. But otherwise, thanks for watching. See ya.